Okay, so question 4. We got a lovely GP question. So a cyclist has a mass of 64 kilograms. We're happy with that, 10 kilograms. They ride from a flat road to the top of the hill. So they're going down there and they're going up to the top of a hill. The top of the hill is 24 meters above. Perfect. So we don't need to change that. It's in meters. Calculate the GPE, and it tells us GP equals M times G times the change in height, and it tells us that G is 10. So it's just times all of those numbers together. So 64 times 10 times 24, 15,360 joules. Lovely question there, nice easy one. It then says the cyclist returns to the flat road at the top of the hill, and now they're going to go back down. So clearly they're going to take their 15,360 joules and lose it down. And it says the mass of the cyclist is 64. Calculate the kinetic energy when the cyclist is travelling at 6. And we should see it should be less than what they started with at the top. Now, it tells us we can use half mv squared. So it's remembering to square that. So 6 times 6 is 36. And there's the crucial bit. And this is 0.5 to put it in a calculator. So put it all together. 0.5 times 64 times 36, 6 squared equals 1152 joules. On to the next part. The cyclist then uses the brakes to stop. So we know that those brakes are going to get hot. So what happens to the kinetic energy? Well, it's going to get transferred to thermal energy. And that thermal energy is then going to get transferred into the brakes, and then ultimately it's going to dissipate into the air. And we've done that so often now in terms of just learning that sentence. So the kinetic energy store is decreased. It's transferred into the thermal energy in the brakes, and this will then dissipate into the air. 2 marks. Now we've got a Sankey diagram, and it tells us 24,000 has been put in to the motor. 19,000 is useful, so that's the supplied or the input. So supplied 24,000. How much is wasted? Well, if this is the wasted bit here, it's going to have to be the 24,000. Take away the 19,000 because energy is conserved. Total energy in equals total energy out. So take those away, and we've got 5,000 joules is wasted. On to the next question. Calculate the efficiency. So that's the useful divided by the total, and we've just circled those. 19,000 divided by 24,000. That's our efficiency, and we're just keying in on what bit is useful. So 19,000 divided by 24,000 equals 0.79. And remember our little form and triangle: efficient, useful, tools. Well, that's useful output, and that's total input. There you go, that's question done.